For my capstone, I built an automated maze-solving robot. The goal of the project to build a robot that could solve mazes autonomously. This means the robot would solve the mazes without any input. The main reason I chose this project was because I just like coding robots in general, but the way it's useful in the real world is that there are obviously already robots that navigate places using the same technology. Instead, these robots have more complicated programming, which lets them avoid all obstacles, not just the walls of a maze. This project is a pretty common one, but it's done differently. In the video you see here, the robot uses line following to find its way through the maze. It probably uses line following because this robot's slightly different than mine, and it can't stay centered as well because the wheels are less accurate. Using line following allows the robot to know what angle it's facing instead of having to be on that precise angle with the rotation. One of the main problems I had was controlling the motors properly. To fix this, I had to set up a controlled experiment to trim the motors. I had to do this because the motors did not turn exactly the way I wanted it to when I wrote it in the code. So I had to find out what numbers caused the motors to do what, because each motor on each side did different things. This project clearly required coding, but there was not as much as I thought there would be. The code I used checked if there was an object in front of it, and then it went forward, and then stopped when it saw an obstacle. Then it turned right, checked if there was an obstacle. If there wasn't one, it would go forward and repeat it. But if there was an obstacle, it would look to the left instead, and then go forward. Or if there was an obstacle, just repeat the whole thing over again. One of the main challenges, as I mentioned before, was trimming the motors. But another challenge I encountered was that the robot would not actually act like it saw the wall, and it would just drive over the wall, or try to, causing itself to flip over and eject its batteries. The way I fixed this was I had to also, like I trimmed the motors, trim the ultrasonic sensor until I found a range where it would work consistently with how I wanted it to. The main thing I learned in this project was how refined your code has to be to make something work perfectly all the time. I had to adjust the code a lot to make sure it would go the right direction and move and stop at the right time, but even with that, it obviously wasn't perfect. If I did this again, I would even trim it even more to even more fine point, and also make the maze more complicated so that I can demonstrate how smart the robot actually is.